So, continuing scalar multiplication with vectors. Very exciting. So we have three vectors and they're multiplied by two scalars, m and n. We don't know what m and n are, but it wants us to find what they are. So we need to first substitute in to this equation here. Okay, so where the e is, we substitute in the values that it gives us. That's the e. So e equals m times the f. So the f is 4i. Find what m and n are. So we have two unknowns. So you may remember from grade 10 that we have two unknowns, so we need to use simultaneous equations. Now, how do you find simultaneous equations with vectors? Well, because it's in Cartesian form, we have all the i's and we have all the j's. So all the i's, multiply this out, we've got 4mi. Multiply this out, we've got 3ni. Divide everything by I. We're left with 1 equals 4m plus 3n. So this is our first equation for our simultaneous equations. Now we look at the j's. We got negative 5j by j's. We're left with... Now if you look at the first equation and the second equation, it is a simple elimination. So we can just take equation 1 from equation 2 and that will eliminate the n's. So you need to communicate this. Equation 1 minus equation 2. We're left with 1 minus negative 5 on the right side of the equals. We have 4m minus negative 2m, and 3n minus 3n is 0. So you're left with 6 equals 6m. The m is therefore equal to 1. Okay, so we found the first unknown scalar. Now we need to find the n. So you can substitute this m that you found here into either 1 or 2. I'm going to sub in m equals 1 into the first equation. 1 plus 3n. Negative 3 divided by 3 equals n. Therefore, n equals negative 1. And that's it. If you would like to check if you got it right, you could sub them both into equation 2, see if it works. But it's not necessary. From linear equations, length, or Pythag, so length of 6, the distance formula is the x squared plus the y squared. So 36 equals x squared, 4 squared is 16. 36 minus 16 is 20. X equals square root of 20. Nice and simple. That's part A. Okay, so confusing. You may have no idea what to do. Parallel to vector u. So scalar rules tell us some scalar k times t equals u, because they're parallel. So say this is t and this is u. They're parallel, so they're going in the same direction. It's just to make it equal, you you just multiply by some scalar. Okay, so how do we use this? We'll simply substitute in t and u. Okay, so now we have the i's and j's again. So similar to the last example, we want to isolate the i's and isolate the j's. The i's, we have kx equals 3. Okay, two unknowns there, too difficult. Isolate the j's. K4 equals -2. Okay, simple. Isolate the k equals -2/4, which is -1/2. Alright, so we put that back into the I equation. So -12x equals 3. Multiply both sides by -2, you're left with x equals -6. There you go. You've solved both cases for the unknown x. I hope that was helpful.